Good morning, ladies and gentlemen. Your host, Golden Zulu. So today we have one interesting subtopic under sets, that is rational numbers. So when we talk about rational numbers, we first define what rational numbers are. A rational number is a number in a decimal form whose block of digits terminate or repeat. Here are some two examples which you have of rational numbers. So the first example that we have is 0.75. So this 0.75 is what is referred to as a terminating rational number. Why? Because it does not continue, it just has a fixed number. Then another example that we have here is 0.245 with a bar like that. So the bar on top of 45, which means that the digit 45 repeats without end. What I'm trying to say here is 0.245. It will continue going without end. So for us not to put this, we'll put bar. Why? Because we are mathematicians trying to simplify an expression. So apart from that, we need to know to say a rational number can also be expressed in form of P over Q. So this is one general thing that you should know about rational numbers. They can be expressed in that form where P is the numerator and Q is the denominator. In such kind of expressions, we have 3 over 4, 27 over 110, 20 over 10. All these are rational numbers. Then we want now to explain further what rational numbers are. Do they also touch the integer part? So note that 7 over 1 is equal to what? 7. In general, n over 1 is equal to n. This is what I'm trying to explain. Where n is any number, we know to say if any number is divided by 1, it is that number. So for any integer n, it is a rational number. So 7 over 1 is equal to 7. In general, n over 1 is equal to n. So for any integer n, all integers are rational numbers. Then, when a rational number is written in the form P over Q, the decimal form of the rational number can be formed by either dividing 4 into 3, where we get 0.75. If you were to divide 110 into 27, you will get 0.245, where it will now be repeating. And in general, we had defined our rational numbers to be those which can be either terminating or repeating. So we will solve interesting questions for us to understand further what rational numbers are and how they can be expressed in the form of P over Q. So watch closely to how we will solve the following examples. So with us, we have this example. Express the following in the form A over B, where B is not equal to 0. The reason why we have said B should not be equal to 0 is because the expression will be undefined. So we want to express 0.3 bar in the form of A over B. So how do we do this? We can remove the bar by putting 0.333 of, if you want, you can continue putting your 3's. So we'll just do that to show it is continuing. Then, for us now to be able to express 0.3 bar in form of that, we will say x should be equal to 0.333. Remember, these 3's are continuing. Then now you need to ask yourself a question. The bar was on 3 only. Then you will ask yourself, which number has 1 0? Because this bar was only on 3. So that number is what? 10. So you will multiply this by 10. So 10 by x, you will get 10x. This by that, you will get 3.33. Then now you have two expressions. You have this expression and this expression. So you will now get this expression and put it under this expression you had written. So we can just put 3 3s like that. We know to say in common sense this they can continue, also this they can continue. Then from here now you subtract. So 10x minus x, that is 9x. Then you know to say 3.33 minus 0.33, you will get your answer to be 3. Then you want to find the value for x. So it is the value for x that you will find that will enable you to make it in form of a over b. So from here you can cancel what is common. 3 there, 1. 3 in here, 3. So that if you divide again, 1 divided by 3, it will give you the repeating number. So this is how you express 0.3 bar in form of a over b. Secondly, we have 0.24 as our example. So secondly, we have 0.24. Remember, this bar is on 2 and 4. So what we generally do here is we'll just increase the number of repeating digits. So 0.24. Remember, the bar is on 2 and 4. So we can again say 24. Remember, these they can continue. So we'll say x should be equal to 0.2424. Then remember, these in common sense they can continue like that. Then you will ask yourself a question. The bar was on how many digits? It was on 2 digits. So which number has 2 zeros? That number is 100. So 100 times x, you will get 100x. Then 100 times that, you will get 24.24. These they can continue going. So now you have two expressions, this expression and that expression over there. So now you will get this expression and bring it down. So you have x 0.24. If you want, you can say 24 here, also 24 here. In common sense, remember these they can continue. Then from here you will subtract 100x minus x, that is 99x. Then from here 24.2424 subtracted by this, you will get your answer to be 24. Then from here you will divide both sides by 99 so that you find the exact value for x, which will enable you make 24 over 99 in form of a over b. In this case the answer will be 8 over 33. So that when you punch, this will continue giving you the 0.2424 to be the repeating numbers. So this is how we make 0.24 to be a over b. The third example that we have with us is, so for here what you can do is you can pause the video, you try to solve this very question. While you are pausing the video, remember to share, like, comment and subscribe. So we continue from here. We know to say the first thing is the bar is on 2 and 3, which means 2 and 3 are repeating digits. So we have 1.2323. They can continue going like this regardless of any state. So what we usually do here is you will say x is equal to 1.2323. These they can continue going. Then from here you will multiply this with 100. The reason why we are saying 100 is because the bar is on 2 digits. So we will say 100. Then 100 times that, you will get 100x. 100 times this, you will get your answer to be 123.23. These 2 3s they can continue going. So we will just put endless dot to show it is continuing without end. So from here we say 1.2323. Then from here you can subtract the two equations. So you have 100x with that. So 100x minus x, that is 99x. Then you know to say 123 minus 1, that is equal to 122. Then this side will give you a 0. Then from here you will divide both sides by 99, where you will now say 122 over 99, giving you the same. Let's just leave it here. This cannot be expressed in its lowest term. So this is the expression that we have expressed in form of A over B. So that if you were to punch it like this, it will give you the same repeating digits. The fourth example that we have with us here is, so the same explanation is attached. So remember, the bar is on 85. So you will have 0.7, which means 85. They are repeating without end. So we can just put dot to show they are repeating without end. Then from here, you will say x is equal to the same number, which is 0.78585. Then immediately you have this. Remember, the bar was on how many digits? 2 digits only. So which number has 2 zeros? That number is 100. So 100 times this, you will get your answer to be 100x. This times that, you will get your answer to be 78.58585. These, they can continue going the 85s. So which means you have two expressions, this expression and that expression. You will get this expression and put it under the expression you are forming, where you will have the same expressions here. Then immediately you have this, you will now subtract the two. So 100 minus x, that is 99x. Then you know to say, if you were to subtract 5 minus 5, 0, 8 minus 8, that is still a 0. 5 minus 5, 0, 8 minus 8, 0. Then from here you will borrow a 1 from 8 and put there. So 15 minus 7, you will get your answer to be 8.77. Our main area of interest is to find x, where x will be equal to A over B, which is the expression of a rational number. Then from here you will divide both sides and you will have x, which is equal to, remember, if there is a decimal here, we'll multiply it with a number with only the number of decimals, which are this side. So if there is 8, it's 10. If there is 82, it's 100. So we'll multiply with 10 both sides. So we have 778 over 990. So we'll try by all means to put that in its lowest term, where you will have your answer to be 389 over 495. So this is the rational number of expressing 0.785 bar in this form, so that if you were to get this number, it will give you the 0.78585, which the 85 will continue repeating without end. Your host, Golden Zulu. Remember to like, share, and subscribe.